So let's do one example on natural language processing. Okay, online retail. Okay, we'll take this one. And order reviews. You see this order reviews? Okay, so see this, right? So this is a table, okay, which has review ID, order ID, right? So review ID is the primary key for this table. Order ID is the like when it's an online retail database, okay, and this is for a Brazilian company, okay, and the text that you will see here, this is a Portuguese text, okay. So we'll see how to handle Portuguese text. Doesn't matter, as long as it's text, the process is same. So purposely I've taken this so that we can see how this the Portuguese text work. So you have review ID, you have order ID, and you have review score here. Okay, so review score is out of 5. So if you see in this case, it has score of 4, 5, 5, 1, 5, 5, 4, so on. And then you have review comment title, right? So this fellow has not given any review. So title is empty and message is also review message. So sometimes we just give rating, we don't write a message, isn't it? So and sometimes, of course, you have, this is your review title and this is your review message. So we need to read this table, right? We need to read this table here. Now, how do we read this table? We have to say
PD underscore read, sorry, PD dot
right?
read underscore CSV.
So before we need to import, right? Import pandas as PD. But you see, I told you, right? It's a fresh installation, so it's not there here. I need to install it. So where is the view tool windows, okay, and terminal, okay. And if I do pip install here, since I've added to class path, it should work, right? I have to accept it. It's working in the background. Okay, so it's running here. And then we'll say data frame equal to PD dot read CSV. Okay, great. So we have read the data frame here now. Now, once we read this, okay, so see, let's look at the different steps that we generally perform in NLP. Okay, natural language processing. Okay, so very first step is, okay, since we're handling with text, right? First step you follow is you convert the entire text to either uppercase or lowercase, right? But we prefer lowercase. I told you, right? Lowercase is good to, to our eyes. So, we convert into lowercase. That's a step number 2. Okay, now every language has some text which is not which cannot be processed. Now, if you are handling English text, okay, then it's not a problem, right? Every English text is can read, but generally European languages, Spanish, French, okay, Portuguese, or some other languages, they have some text which is apart from those 26 characters, right? So they'll have a dot dot a to the power something. So if you're handling non-English text, okay, especially European language, then you have to do decomposition. We call it as decomposition. Decomposition. Decomposition is convert non-English characters into English characters. Okay. So this is one. And next is, okay, you have, again, this holds true with non-English letter. And that's why I took Portuguese, okay? So you can perform all these operations here. It is called accent removal, okay? Accent removal is more like, again, non-English characters, but, you know, it is, it does not mean anything, okay? When we, like, you know, I'm just talk about Hindi words, let's say, you know, you say G or Garu and things like that, right? So we add this to, which is very specific to that language, but in a way, it does not give any meaning, right? So, you know, so we remove what is called as, we will ignore the words which have no meaning. You can't translate exactly those words into English, right? You can't exactly translate those specific words. Okay, so we call it as, you know, converting into UTF characters, the standard. UTF is the standard. So we'll convert into UTF characters. Okay, then the next step is tokenize. Okay, tokenize is converting your sentence into words. Okay, convert sentence into words. Okay, so if you have a sentence like I am going will become 3 different words. Okay, the purpose of converting into into words is that we can remove the words which does not make sense. Okay, which does not make sense. So we call them stop words. Okay, now for example, if I say we are going, suppose, now going is what will make sense to your analysis, right? Are, a, and the, these words are important to form an English sentence, but but see, when somebody says something, right? Let's say we are not going to have class tomorrow. If I say that, okay, so not class tomorrow is what stuck to your mind.
Yeah.
Other things are words which are added to make it as a perfect English statement, but that does not give any meaning to it. We call them as stop words. So once you, because see, if you have a text, okay, which has 20 characters, analyzing 20 characters, okay, might be difficult. Okay, more you know, characters you have, more complex your algorithm will become, right? That means dimensions we have to look into the problem. So that's one. Second thing is, anyway, that's not going to give any meaning. So remove. So just like in machine learning, what we do is we remove the columns which are not relevant, which does not have any impact on the analysis. We remove such columns, right? So stop words will help you to remove those columns. Sorry, columns in the sense words here. Later it's going to become a column. Each word is going to become column later. But right now we are still handling the text data. We are still handling the text data. So we call them as stop words. Okay, so you know, it's like the removal of stop words. Okay, so removal of stop words are words which doesn't carry or give any meaning. Okay, those are because we cannot form a proper English sentence. Like, you know, so when you do a Google search, right? So you don't exactly type I am looking for this, right? You'll just type the keywords there. So that's like removal of stop words, right? You remove the stop words and only give keywords in the Google search. Okay, so this is your removal of stop words. Okay, so these are, okay, the minimum basic steps that you perform on natural language. Now you have words which you can use it for your analysis. Okay, so okay, and then for depending upon specific case, we will perform different steps. Okay, so let's stop here for this example, and I'll tell you more steps. Okay, the next, these are the 5 steps that you'll have to do it with any NLP, any kind of text analysis. Convert into lowercase, do words. That way you'll remove your colon, comma, spaces, all those things will be removed. Remove the stop words. So now you have clean data for your analysis. Okay, so let's go and see how we work with this. Okay.
Yes, sir.
So first thing is convert text into lowercase, right?
Yes, sir.
So this is our data, and which column are we talking about? We are talking about column, let's say review comment message. Okay, this will have your message here. Okay, okay, so I'm going to say here text text for analysis, something like that, let's say, or analysis text. Okay, we'll try to keep it simple. Analysis text, something like that. So this is going to be your text df of this particular column, right? Now when I run this, I should see what is that column values. Right? So we have it here. Okay.
Yes, sir.
Now we don't want the null values, correct? We don't want the null values. So what I'll do is, okay, when I don't want null values, I will say in text df, okay, in text df, look for text df content. Okay, this is how you handle pandas, right? So in text df, okay, I want these values, okay, to be not null, not null. Okay, and that I'm going to copy it to the analysis text. Okay, so now if you see this, nan things should not be there.
Sir,
Yes.
can you just repeat, sir? Sorry. This I understood printing analysis part, but after that, what was done, I didn't get. I mean, I didn't listen.
No. What I'm saying is, I'm taking text data, but out of this text data, I'm taking the column which the review comment message is not null.
Okay.
Okay, I'm taking this review comment which is not null.
Something is there, in the sense it is not empty, something is there.
Correct.
Yeah. And after that?
That's all. And I copied it to analysis text.
Okay.
Okay.
Fine.
So analysis text here, okay, is copying the entire thing to analysis text where message is not null. That's what copy will do.
Okay.
Okay. Now, okay, so this type, if you look at the output, what is the type of analysis text? Data frame only, right?
Yeah,
if you want, you can do the type, because copy will create a copy of data frame. So it's no longer a column. Earlier, when I didn't do copy, we had a column before,
Yes, sir.
right? But
Yeah.
now we don't have a column. It is a
Okay, data frame.
data frame, isn't it?
Okay.
Yes. Now what I'll do is in this data frame, okay, in this data frame, I'll create a column, okay. So I'm going to say analysis text, okay, and I'm going to say review text or something like this. Okay, so review text equal to, okay, review text, and in review text we have to convert everything to lowercase, isn't it?
Yes, sir.
So this is the text analysis, okay, and in this I have this column, right, which has the review comment message. Yes. So
Yes,
I
sir.
created an analysis text, which is data frame with not null values. Now what I'm saying is I'm creating a new column on analysis text data frame. And I'm saying this is same as review comment message. Okay. And okay. Now what we'll do is we will apply, okay, a function here. We'll apply a function on it. Okay. So let me write my first function here. Function one, step one, right? To lowercase. Lowercase, correct?
Yes, sir.
So I'm going to say def convert into lowercase or something. Okay. It will take the text message here. I'm going to say comment message or something. Okay. And I'll convert this into lowercase. Okay. So lower case equal to your comments dot lowercase, lower, right? This is going to convert into lowercase, correct? So now if I go here, I will say analysis text, okay, review text message dot apply. Dot apply. Okay, apply what? This function. Okay, now if you print this, okay, now you can see this before and after. Okay, so let's comment it out. We can't see all, right? So let's see if this has successfully converted into lowercase or not. Oops, review text is the error. What is the review text here? Oh, review text we are creating here itself, right? So we will call this review comment message. Review text is created in next line, isn't it? So if you see review comment message, which it will have, of course, it will not have null values, right? Because we have removed the null values, but it will have the text now, and the text will have some capital letters also. So see, it has some capital letters, isn't it? Now, when I comment this, and after, convert into lowercase, if I run it, now all the context should be converted into lowercase. Here also type. Okay. So, okay. So we'll get lowercase. What is the next step? Okay. Next, see. Oops. No, something gone wrong. Okay. We have not returned it, right? I have to return that, right, from the from this. All right. It's returning blank, right? That's why it's all became none. Right. So now we will have the lowercase return. So see, everything is now smaller, lowercase. Yes, so far?
Yes, sir.
So we have done our
And it
step
is
one.
series thing, sir. Previously, when we have printed this type, it is showing series.
Series, because I'm looking at one column, right? I was not looking at the entire. I was saying type of this one particular
Okay.
column.
Yeah, yeah.
Each column is series, and when you combine series, you get data frame, right? So
Yeah.
I was looking at type of,
Okay.
right? This. So
Yes.
if I just say type of analysis text, you get data frame. Type of
Yes.
analysis text of review text, you'll get series.
Okay. Done, sir.
Yes. Okay. So our step number 1 is done. What is step number 2? Decomposition.
Yeah.
Okay. Decomposition and okay. So what do we do here now? Okay. And UTF words, right? So what we'll do, we'll combine both these two steps together, converting into UTF and non-text. Okay. So this is I'll put it in the same function. Okay. Why to write another function? I write another function, right? But I'll put it in the same function.
Yeah.
Right. So here, okay, you will get, okay, I'm going to say lowercase, okay, or I'll say Unicode, okay. I'll say Unicode equal to, okay, Unicode equal to, okay, and for this I need to import Unicode data, okay. Import Unicode data will actually convert the text into Unicode for us. Okay, so I'm going to say Unicode equal to Unicode data dot you have normalize function. Okay, so normalize will take on what on what language. So see, so we have something called as NFKD. Okay, NFKD understands all these European languages. Okay, so I can show you a bit. Okay, so that there are different ways of doing your Unicode normalization. You have NFD, NFC, NFKD, and NFKC. You can use any of these. Okay, NFKD. Okay, and you can, so these are designed to work with non-English text. Okay, so if I say NFKD, okay, the Portuguese language. Okay, so so see, NFD and NFKD decompose each character into 2 Unicode characters. Okay, and that is being read by the English character. Okay, so this step you won't do it if it is a English text. Only if it is a non-English text, we prefer this method. Okay.
Yes, sir.
So I go back and I say NFKD. Okay, on what? The lowercase text. Okay, and we'll say if you, okay, so encode first, encode, okay, and encode into ASCII character. And if there is an error here, when you can't convert into Unicode, ignore the errors. Okay, so I'm going to say errors equal to ignore. Okay, that's okay. If it is not able to convert, if it is not able to convert a certain text into Unicode, okay, we are not bothered. Okay.
Why will it not be able to convert, sir?
Not all can be converted into English text, right? You can't convert everything into English text, isn't it?
Yeah,
and if something is not converted also, you say, okay, I'm not bothered. So first you encode and now it is removed and now we decode it back into our UTF. So we encode, remove these errors. Now we convert it back into UTF. So now we need to return Unicode here, right? So can I see some text here? You see this parabens, right? Now let's see this, what happens. See what happened to parabens? It became an English text, right? You had that sign on top of it, right? Yes, no?
Yes, sir. Yes, sir.
So it has converted into your English text now. So now we can handle our other steps. Okay. So this is it. Now I told you we can remove the accent words, right? Accent words are words which we don't really use or does not have any special significant meaning. Okay, accent words are different than stop words. Stop words are English words. Okay, but accent words are specific to the language. Okay, that those are not English words. So to remove accent words, okay, we need to okay, so you have this now, right? Every language will have some words, okay, which are accents words, right? I told you, like G, Garu, like
Yeah,
they don't
yeah.
have, you can't translate exactly into English, right? So we need to remove, let's say, this word, okay? Now what we'll do is, okay, we will not remove this now. We will remove the stop words. Along with stop words, we will add this. You can do it now, or you can do it later as well. Okay, so what I'll say in stop words, when removing a and the and etc. those words, we will also add this now. Okay, we'll remove it. Okay, but to remove it, we have to convert into words. Then only we can remove those words, right? So we'll now break it into words. Okay. So
Yes, sir.
so we have, right? So now we have to tokenize. Tokenize is into words. Okay. So I'll say words equal to, okay, NLTK. Have we? No, we have not imported NLTK, right? So I'm going to say import NLTK. Okay. So NLTK is the library, okay, in Python, which helps us to do NLP analysis. So, you have to install NLTK if for doing analysis here. So I'm going to view, I'm going to terminal, and I'll say pip install NLTK. Okay. So now when I say NLTK dot, this error should go, right? Gone. So when I say NLTK dot, you have tokenize. Okay, tokenize. Tokenize dot word tokenize. Okay, so I want to convert into, so you have multiple tokenize, blank line, line tokenizer. We need word tokenizer. We want to break it into words. Okay, word tokenize, and what to tokenize? The Unicode value. So now we are tokenizing the Unicode. So now let's return this word here and see what we get. So we'll get words now, right? And now last thing from that we'll do is we will remove the words here. Okay. Okay. Okay, this was spunt not found. Yeah, we have to do this also. Punct is a dictionary, okay, which has all the, see NLTK when I said, right? NLTK library has a list of stop words and all those things. So this is the database. Okay, this is the database that is there with NLTK. Okay, so you have to call this database. NLTK uses this database, punct database. Okay, so when you say list of stop words, one is you create your own list of stop words. You can do that as well. Simply, remove those words using the string function, or you can directly ask NLTK to give us the list and it will remove, and we'll see that in the next step. So now when you see this here, see it has converted into list of words, isn't it? Now from this we need to remove words which are not important. Okay, from words which are not important. So we'll remove stop words and the accent word both here. So I'm going to say here build stop word, or not build, right? Build is not right word, right? Because it's already there. Get, okay, stop words database. Okay, so I'm going to call it as let's call it stop words only. Stop words. So what is your stop words? Stop words, okay, is nothing but your NLTK dot corpus. Okay, corpus has list of words. Okay, the different database, and here we have something called as stop words. Okay, NLTK dot corpus dot stop words, and then to get the words, you get words. You can say the language. Okay, you can, it has multiple languages. Portuguese is there. You can use even English here. Okay, so this is your Portuguese. Okay, so this will give us Portuguese list of stop words. Yes.
Yes, sir.
Okay. Now, so this is the database where we have created the stop words. Now what we have to do is we have to pass each of our members, each of our string into stop words, and the stop words will remove it. Okay, so here I'm going to say this was created for this, right? So we'll say function to perform all the analysis. Okay, we are performing all the analysis here, including converting it to lowercase and all. Okay, so now we have to write a function, okay, which will remove the stop word, the text, the stop words from the words that we have. Okay, so what I'm going to do is I will write a function. Okay, and function has to be written before this, isn't it? Because function will use stop words. So stop words has to be declared before you call this. So I'm going to use a function here, function to remove stop words. Okay, and I'm going to say def remove stop words. Okay, and this will take text as input, and it will return. So in fact, I was thinking, instead of doing this, we can directly perform in the same function, right? Why to create a new function? Okay. Okay. Let's see if I can perform here. Okay. See, the why I was thinking to do function or not is here we have to pass one by one, right? So is it possible to read through the entire text and read one by one and throw it out? So I'm thinking if we can build a loop, for loop, okay, and that way we can pass it, right? Okay. So, okay. So I'm going to build a for loop and see if I can do it within this. Okay. If not, we'll go back here. So I'm going to say for, okay, for W in words, right? So this is the words, right? And we're going to take each word from there. So for W in word, if W not in stop words, right? If W not in stop words and it is alphabet, right? We don't care if it is not alphabet, it is alpha. Okay. So, okay.
Sir,
Sorry. So for W in words, if W is not stop words and if it is not this, then I need the W. I need that word.
So why are we doing for only W here?
What is W? W, each word in words, right? I'm taking each words here. For W in words means what? W will take each word from the words, isn't it?
So in place of W, we can place any alphabet else.
What is this? Yeah, this is for loop.
For that I understood, sir. Is specifically you're taking W for W, right?
W
so
indicating word, right? That's why I took W. Just to, you can take anything. You can take X, Y, A. For I,
yes.
why you're taking I means what should I answer? You tell me.
Yeah, that is in general, no, sir. Yeah, in that sense only, did you consider or not? I'm asking. That's it.
Correct.
Yeah, thank you.
Okay. So for
Yes,
W in words means W will be each member from the words, right? For I in range means I will take each member from range, right?
Yes.
So I'm using W here. W short form for word, basically. That's what.
Okay.
You can write word here. You know, if you want, you can write word if you want to be that specific. That means each word from the word. You're taking each word from the word. And if that word is not in stop words and if it is alphabet, that's when you want that word to be. Okay, I'm only interested in the words which is not in stop words. Okay, which is not in stop word and which is also alphabet. That means if numbers and non-alphabet, I'm ignoring. Right? I'm ignoring. Okay. Now this one, what I'll do is I will convert this into a tuple. Okay, I'm converting this into tuple. And this is the word that you are interested in. So new words is this. So you have the words that we got after tokenize. I'm removing the stop words. Right? But see, we have not yet removed the now, right? Okay, so one more thing we can do is but see, stop word, is it a set? Okay, stop word needs to be a set. Okay, let's see first. This will throw error. Okay, because stop words needs to give us the output as a set, not like this. Okay. Okay, so the words we need should be a set. So what is happening now? Attempting to load stop words. Okay. Okay, I have to download stop words also. Yeah, this is the problem. Okay, so from the NLTK dictionary, now I'm going to use this stop words. So these are the dictionary, okay, which are already there in the NLTK. So that you don't have to build it again and again. You don't have to build that list. But of course, you can build a list, right? You can build a list of words and you can remove them, right? But here I want to use the inbuilt library to remove the stop words. Perfect. Okay. So it is stop words also removed. Okay, but see, everything is done. Okay, is everything done? Now we haven't created. So but I think this should be fine. Okay. Okay. So what I'll do here, I want to remove now also, right? And I'll say, okay, if word not in stop words and word is alphabet and word not in, correct? Not in I don't want now. Okay, this is the accent. NAO, right? Now, NAO. Okay, now let's run this and see. So our word is now cleared. Okay, let me comment the stop words also. Once it's now, it's a one-time thing. Okay, this is one-time thing. Now you see your now is also gone, right? You don't see NAO, right? So now we have the words which we can use. So these are the basic analysis that you have to perform for any text analysis, right? So these are the steps we have performed, and now we have, okay, we have a text data which is ready for our analysis. Okay, so these are the minimum steps, common steps whenever you're handling text data, NLP, and text. NLP basically means what? String analysis, right? So whenever you're doing string analysis, these are the minimum steps you need to perform. Okay, and now you have a text which is cleaned and ready.
So can you just like fastly revise whatever we have done till now?
Okay, read this and we'll discuss then.
Yeah. Yes.
So first convert into lowercase, then normalize the text. Okay, then convert into words. And now I'm removing the words which are, so so I'm keeping the words, not removing the, I'm keeping the words which are not in stop words and is alphabet and also not in NAO. NAO is not a stop word, okay, but I don't want NAO, so I'll remove it. If I convert into set, okay, I think the output has to be as a set of these words. Okay, now you see we have missed one important aspect. Okay. We have missed one important aspect. Okay. The aspect is, see, we are taking stop words from Portuguese, isn't it? Correct. So the stop words has to be removed before we perform normalize.
Convert into English. Yeah.
Yeah, because that those are our Portuguese words, right? See, we're taking stop words from Portuguese, but before that we have converted the text into English, right? Not good. Okay. Okay. So normalize argument must be string, not tuple. Normalize. Where is normalize? Here, right? And we are converting into tuple. Okay. So this is not good. Okay. Or else what we can do is, we will normalize this stop words only, right? Because see, it is expecting string. It is expecting us to pass the columns. Okay. So what I'll do is just like we normalize this one here, right? I will normalize stop words also. Okay. So shift end. Okay, I'm going to copy this. So now this is your stop words, right? So I'm going to say, okay, for okay, so this is your stop word, right? So for each word in stop word, okay, for word in the stop word, okay, for this word in stop word, so this word is now the word, Portuguese word, and I need to run right this stop words here. Do you get it? Now let's see this. Okay, I missed this step. See, the original word also will be Portuguese, and we are converting into text. Where is that? Okay, normalize is taking, must be string. So what I'll do is we'll write a function for this. Okay, so instead of doing this, I'm going to say, okay, function to normalize text. Okay, and def normalize text. This will take word and this will return you each word, right? Because we have multiple words, right? So that's why it is not working. So I'm going to this is the one, right? So I'm going to take this and put it here. Okay, and so this word is what we are taking. Okay, so now here, okay, so each word in this thing, okay, and this word we will now pass to, okay, this word we will pass to this function, right? So what output you are getting, I will apply this remove normalized text on this W. So each word is being passed. That's why now word is a string. Each word is being passed. Okay, and we'll just say we can take set or list, right? Set is better because it will remove the duplicate words. In case we have any duplicate words, it will be removed. So now why this is error? For word in this Portuguese, okay, and normalize word set one. Okay, there's extra bracket. Yes. Now this is the actual stop word. Now when we run it, we'll not get this string error because we are passing set, right? We should pass string. So each word we are taking, sending it to normalized text and storing as a set here. Tell me one by one, what step did you understand? What step you didn't understand? I'm converting into lowercase, okay, and then I'm converting each word into a normalized text, right? Removing all the accent or the words which are non-English characters. So Unicode is that word, and now I'm breaking into words. Now each word, I have to see if the word is in stop word or not. If it is in stop word, remove it. Okay, so words will be removed from stop word. So you get this. How to generate stop word? So we are taking this NLTK corpus stop words Portuguese. This will give us the words in Portuguese. But see, we have already normalized this text here. So we need to normalize this Portuguese words also. So I'm taking each word and passing to a function which will normalize. So here we have multiple words, right? It's not just single word. That's why when we ran it, it gave error, right? So we are taking each word, passing to a function which will normalize the text. And now you get set of normalized words. So we are taking the Portuguese original text, normalizing it, keeping it ready, taking the words, okay, from the stop words, normalizing it, so that now you have both Portuguese words but normalized for English. And then we will remove it from the stop words. Done. So now what we have is normalized words which we can use for our analysis. Okay, so I'm going to repeat it again. Okay, so I have taken this review comment message column, okay, and I have removed the null values and copied to a new data frame, right? You can copy to same data frame also, not a problem. I can say data df, whatever. Now I'm taking this comment message column, okay, and on this, each of the message from comment message, I am performing this function. Okay, actually I wrote convert into lowercase, but it does everything actually, right?
Yes.
So after applying this output, I'm storing in a review text. So if you want to print here, you can print analysis text, comma review text. So it will tell you review text is the process text and review comment message is the original text. You saw the original text and the reviews text. You can see the difference. Okay. So what all steps did we perform? So we first converted into lowercase. Then we normalized non-English characters, something which is apart from those 26 characters. We go to Portuguese and French and Spanish, you will see there's some extra characters, which those characters we cannot process. So we have to normalize it. So we normalized it. Okay. After normalizing, we broke into words. Now each words we will take and remove the stop words. So for that, we are dependent on inbuilt stop word library. Okay, so we are taking the stop word library, but the problem with stop word library here is that this is a Portuguese word. And we have already converted the original Portuguese words into English. I mean, not English, but tokenized, or sorry, standardized, right? So but if you look for exact Portuguese words, you won't find it because the text has already been normalized. So we are going to Portuguese words, taking the stop words, and we are normalizing the stop word. So we are taking each word from corpus and then we are normalizing same formula. We are applying on top of it. So now the main text is also normalized and this database is also normalized. Now you go and remove it. So end of the day, we will have normalized text minus stop words. Okay. So this is the minimum steps that you have to perform. Now, depending upon your business problem, you will, use this, whether you want to perform machine learning analysis, which we will do later. Okay. Or you want to perform some other plotting. Let's say we are still in data visualization, right? So we can plot now. So see, each column has these values. I want to see which values are repeating maximum number of times. Okay, so see, the background of this data set is that this data set belongs to a retail company. Okay, let's imagine Amazon. Amazon has all the products, right? They want to know why a certain product, okay, is popular and why a certain product is not popular. Okay, so first of all, okay, we need to know the tone, okay, or which is text which is positive or negative. How do I know? So here you have something called as rating, isn't it? So if I take rating 4 and 5, those are positive text, right? And rating 1 and 2 are negative text. So this is the process text. Now I'm going to take the rating example and I'm going to filter, okay, the subset of this data where the rating is 4 and 5 to know why people prefer or like a particular product. So if I filter it based on rating 4 or 5, I will get text which are positive, right? And then in that case, I'm going to create unigram, bigram, trigram. Unigram, bigram, and trigram are words, okay, generally created from the text, which gives us some meaning, okay. So for example, after all these things, after performing all these analysis, if I get words like don't buy now, for example, okay. Now unigram means one word. So don't will become one word, buy will become one word, now will become one word. Okay, but sometimes one word itself may not give us enough information, right? For example, in this case, if you just see the word buy, sorry?
No, sir. Just if we see buy, the meaning is exactly reverse, no, sir. How
Exactly
to
reversed.
Yeah.
Right? So he's saying, okay, you have to go for buy. So it says, okay, don't look at unigram, create bigram. Bigram are consecutive words, okay? So if I have to do unigram here, unigram will be don't as a single word, buy as a single word, and now as a single word. Bigram, okay, this is unigram, okay. Bigram means two words. So we will end up getting two bigrams here. Don't buy, buy now.
Again with the opposite sense.
Right? But if you see even don't buy also not giving correct meaning.
At least sense is to little extent, sir. Okay, it's not asking not
Correct,
to buy.
correct. You're right.
Yeah.
Okay. So
Yeah.
it is saying don't buy, but again, it's not. So, so you can create don't buy now. So, okay. Here you get only one trigram. Trigram will combine consecutive words. Okay. Not more than that. Okay. So don't buy now. Don't buy now. Don't buy now. No, see, so you just can't make your decision based on unigram or bigram or trigram. You can create tetra, trigram, pentagram. Tetra, yeah, tetragram, pentagram, different grams. But what it says is, maximum, in our language, 3 words are good enough to know, right?
Yes.
This is not a great product. So great product will show you what's a great product, but not a great product, isn't it? It gives a different meaning. So we have to create, unigram, bigram, trigram, and see what is the meaning of it. And that way you will know why customers are actually, preferring a product. So what I'm going to do is, now what I'm going to do is very specific to this data set, right? I'm going to create 2 data sets. Okay, where, okay, create 2 data sets. I'm going to divide this into 2 parts. One is where rating is 5. Okay, and second where rating is, you can say 5 or 4, right? Or I'll say rating is 1, right? You can say or 4 also, right? Okay, so how do I get the data set here? I want analysis text, entire analysis text, isn't it? But in this case, I want which one has a review score of
5
equal to 5, right? So if you don't remember, you can go and copy the exact title here, review score, right? So see, when somebody says buy and gives a score of 1, that means something is wrong, right? But if they give rating 5 and say don't buy, that means something is wrong, right? So this score will give us the sentiment. It's called sentiment analysis. Sentiment. It tells us whether it's a positive. So you have 3 types of sentiment: positive sentiment, negative sentiment, and neutral sentiment. Okay. So depending upon your situation, right? So other day, Karthik was saying, right, buy, what was that? Classification, right? Binary classification. So binary classification really only interested to know whether it's a positive or negative, right? Okay, now here in this case, we don't have to use our brain because rating itself is there. That will tell us. But when you go to machine learning and we are doing tweet analysis, right? By reading the tweet only, we should be able to know whether it's a positive or negative sentiment or neutral sentiment. So if it is binary classification, you use only positive, negative. Otherwise, you can use, neutral. For example, in this case, 3 will be a neutral sentiment, correct? So I'm going to say analysis text, okay, where analysis text review score, right, equal to 5. So now I have data set which are all positive sentiment, and these are your negative sentiment, rating 1. And they won't say negative, rating 1 and then talk great about your product, isn't it? Okay.
Yeah.
Now after doing this, I need to create this bigram trigram, right? So I'll write a function which will do all these 3 in the same function. So def, okay, text, or is there words, right, in a way? So words to grams or something, I call it. Okay, so here you pass words from each row, right? And this will return us, okay, unigram. So I'm going to create 3 variables: unigram, bigram, trigram equal to, and then I'm going to say, sorry, return all these 3 values, right? And in the, okay, there I'm going to catch it. Okay, here I'm going to catch bigram, unigram, trigram for rating 5, word to grams. Okay, words to gram, and I'm going to call it as rating 5. Okay, word to gram, and we need to pass the rating text here. Okay, fine, we'll see that. And here I'm going to call this, I'm going to say unigram 1. Okay, so now let's build this unigram bigram, right? So we will go through each word for W in word, okay, and we will create bigram. So unigram is each word separately, right? So this is word only, right? Words, right? Sorry. Okay, for W in words, so unigram is simple extension. Unigram, okay. Dot extend. Okay, and you keep on adding the words here. So W. Bigram is little different. We have to join the corresponding words, isn't it? So I'm going to say bigram dot extend. Okay, and now we need to join with space in between. So I'm going to say dot join. Okay, join join what? Let's run a loop here to pick one, right? So I'm going to say for bigram in NLTK dot bigrams. Okay, this is going to give us a sequence. We don't have to worry too much about it. Okay, W. This is going to give us this bigram in, right? So each bigram we need to join together. That's it. Okay, and now for trigram, we just have to say trigram. Okay, so what we'll do is we'll put S here just to make it different from the variable that we are using. Okay, otherwise this will create problem. I'm going to say unigrams, bigrams, trigram. These are what we are returning. Okay, so by trigram, right?
Line number 51 we need to check. Yeah.
This is trigram. Okay. So
Sir,
now, yes.
51 analytic or trigrams, no, sir?
Oh, yeah. Correct. Okay. Now we need to pass the, okay. So we have to pass what here? The one that we have processed, isn't it?
Yes,
Not the
sir.
original one, the one that we have
Yes.
processed. We have processed review text, right?
Yeah.
And now the review text, okay, sorry. So I'm reading it from this, but we have created a new data frame. Okay, not the analysis text, but where is that we have created rating 5, right? This is the next data frame that we have created, right? Which is subset of the main data frame. This is passed. Okay, if you want to print, you can print unigram 5. Okay. So let's, what I'm going to do, okay. I'm going to say input. Okay, unigram 5, bigram 5, trigram 5. Okay, and I'm going to run it. Is there a print before? Let's comment all the print before. Yeah. So meanwhile, I'm going to open our Google Translate. Portuguese to English. Okay, let's see if our machine can understand, Google can detect. Okay, so these are, oops. Okay, you see this. Let's copy this and put it here. Portuguese detected, right? Before, deadline, all, yet, install, liked, supplier, have. Now, if you see from this, you know that they liked because, we got the product before deadline. That's why people liked it. Okay. Supplier maybe is good, right? But now we'll go with, we'll hit enter and go to second. Now, these are your bigrams. 2 words together. Great product, everyone perfect, everyone or everything, right? I mean, of course, there will be some error in conversion, right? Everything perfect. These are the reason why they like the product. Great product, right? If you want to see the trigram, okay, you get the trigram, 3 words together, right? Delivered before deadline. Before deadline, recommend, excellent quality product, excellent quality exceeded, right? So of course, this makes sense that these are your positive. Now, we can go with 1. Then what happens? So these are, single word, and probably from single word, very rarely you can make out some difference. We'll be using surveys, probably not, right? Okay. Now when you go, great product, everything perfect. Okay, so see, great product, everything perfect. Okay, all requirements, product arrived, defect arrived. Defect arrived, you can understand. But great product, how can it be 1? So let's see what happened to our third trigram.
Sir, aren't we converting it into English?
No, we are converting the text, the characters which are not text, right? We are not translating.
Okay.
Where did we translate?
Okay. So can that also be done? Like
yes, that also you can do. NLTK can translate also.
Yeah, instead of going and searching.
Right. So you can translate that also. What happened? Okay, something went wrong here.
Maybe customer reviews are like that, sir.
Sorry.
In the sense, I have given rating 1 and I am saying great product.
No,
Maybe
not a great product. Could be not great product, right? Not a great product. A will be removed in stop word. So you have not great product.
Okay.
Right? Just like,
yeah,
okay,
don't buy now sort of thing.
Correct. Trigram is taking some time to build it. Okay, so let's see this now.
First one, we are getting only one word, sir. Why?
That could be in just one word in the whole line.
Yeah, okay.
So whole line might have only one word. So it's not able to form trigram. Right?
Yeah.
Excellent, quality exceeded. Quality exceeded expectation. So, but this is how you can build your, but let me see if I did now I'm getting doubt. If I change this to 1 here, analysis text, rating 5 equal to, okay, so sorry, rating 1, right? And am I passing rating 1 here? See, I'm passing rating 5 only, no?
Yes, sir.
That's why you're getting excellent quality. Definitely these look different than the previous one. Needs to improve communication, communication still waiting for order. Month product delivered, store dispatched product, right? So communication, they are delaying it and they're not informing customer. That's what you feel when you look at these ratings, isn't it?
Yeah.
Okay, so we have done our NLTK. Tomorrow, I will share a link, okay, or I'll share a PDF. Please work on that. We'll connect after 1 hour, okay? So 10 to 11, you work on that. It's a web scraping. We'll do a web scraping. And once we finish this web scraping, we can start our machine learning journey, okay? So hopefully from Wednesday, we'll be able to move to machine learning. So web scraping is a project, right? Same thing that we did in the class, okay, but with different data now. Okay, so tomorrow I'll give you this.